Okay, so here is another problem where we're given cos ratio is 3/4 and we need to find the other trig ratios. Since we're given the cos ratio in exact values, we have two sides of this triangle. Okay, so I'm going to draw this in. The cos goes with x, so my x to my radius, I'm going to say is 3/4. Now, this is a bit of a problem because I don't know, although we know that the x is positive, we don't know the y. We don't know if the y is positive or negative. So there are actually two positions that I have to consider here. So there's another position down here that has the same ratio of +3/+4. Okay, so there's two possibilities that I'm having to consider. So here the sine theta, well, let's solve for the third side here. So 16 minus 9 is going to be √7. So sine theta could be positive √7/4, or it could be negative √7/4. So I'm going to write that in. So it could be √7/4. That's the positive version. Or, since there is another position, there's a second position that has the same cosine ratio, we could also consider that it could be negative √7/4. Same with the tan. The tan here could be from this black position, which could be positive slope. So in this case, it's going to be positive √7/3. But the tan could also be in the red position here, which gives us a negative slope, which is negative √7/3. So because this quadrant's not specified and cosine, positive cosine can be in two different quadrants, we have to consider both possibilities. So even for theta, when I solve for theta here, when I do the arc cos of 3/4, I end up with 41.40 degrees. So 41.40 degrees. Now the calculator only ever gives me one angle, so I'm going to call that one theta1. But using symmetry, I can work out the red position of this. So the red position, I know it could be, I'm going to call that theta2, and that could be negative 41.40, or if I need to measure it in the positive direction, this is also the same, and this is not, these are two different angles here, theta1 and theta2, but theta2 could be written as a coterminal angle as 318.60 degrees. Okay, so these are equivalent positions. These are two different positions here, and theta1 and theta2 indicate two different positions. So there are two different possibilities for this cosine ratio, and that's the case for all the ratios. If we only have the ratio, we have to consider that there's two positions that they can take up in the circle. So that's the difference between the example 1 and example 2. This one here, we know exactly the right position. Although the tan, we have a slope of negative 2/5. That slope could have two positions. We know that it is only in one position because a quadrant is known in this problem. Here, we've been given the cosine ratio. We have no indication of the quadrant location. And cosine, and in fact not just cosine, but the cosine and tan, can take on two different positions. Each ratio can take two different positions. So this cosine ratio can be in quadrant 1, quadrant 4. Sine ratios can be in, has a symmetry across the y-axis, so it could be symmetrical this way. And tan has rotational symmetry, so it could be opposite symmetry. So we have to be very careful to make sure that we know, if we know the quadrant, we give one answer. If we don't know the quadrant, we have to give both positions, both possible positions. So how are example 1 and 2 different? example 1, the quadrant is known. Only one position is considered. Okay, so that's very important. In example 2, quadrant is not known. So 2 positions must be considered. Okay, so this is a very important aspect of circle geometry, is that we may need to consider 2 positions because of the symmetry of the circle.